Hey everybody. So today I would like to tackle these questions of binary bit manipulation. So we just finished a section of array from last week, and starting from this week, I will tackle some problems regarding bit manipulation. And then the first question is this 371 sum of two integers. So the question starts by saying, given two integers a and b, we need to compute sum of the two integers without using the operators plus and minus. So as usual, we're gonna start with the goal setting. So goal is to return a plus b without using Python's plus minus operators. Pretty straightforward. But it seems very difficult because so as a constraint one, AB can be negative. Constraint two. It seems empty inputs are not possible. We can ignore empty case. Okay. How do we tackle this problem? Well, so Python has. So I'm using Python, and Python has some bit manipulation operators such as shift1, to double, and XNOR is this A and B, and so basically use bit manipulators and compute plus and difference. Okay, and then for AND operation we can use AND. We're going to utilize these. So there are two cases that I can think of. Case one is A plus B, and case two is that A minus B, which is equals to A plus negative B. How do we know that? So basically case one is that A times B is bigger than 0. And case two is that if A times B is less than 0. So those are the decision makers. And yeah, so I need some bit explains bit examples to decide what we have to do. So for example, if we have, let's say 7 plus 1, which is 8. So 7 is 0, 1, 1, 1, and then 0 is 0, 1, 1, 1 as a bit operator. So we can just plus or minus. So instead, what we are going to do is use the XOR. So XOR is if the two bits are different, that means 1. So this is 0. So we want 0, 0, 0, 1, 1, 1, 0. So this is still 6 because 4 plus 2 is 6, and we need 2. So we're missing 2. And where can I get where can I get the 2? So we're just randomly playing around with Python's bit manipulator operations. So where can I get 2? If we apply AND operation, that means 0, 0 is 0, 0, 1 is 0, 0, 0, 1 is also 0, and then 1, 1 is finally 1. So now this is 1. And if we apply and also plus 1, then what's gonna happen is that this 0, 0, 0, 1 is shifted to the left. So this is gonna be 0, 0, 1, 0, which is 2. So I think the combination of XOR and shift 1 seems working. So we can delete AND. So 6 plus 2 is 8, which is what we wanted. So I think from the random operation of XOR and shift 1, I think we can formulate something. Then so this is what we're going to do. So another case, so seems like XOR, and then let's name it carry. Let's name it this carry. Let's name this carry. So it seems like XOR and carry can create something. Can make 8. Then actually, maybe we can do, while we have carry, we still need to compute again another XOR is the previous XOR. Let's name it X and the carry. So what I mean is that, so now we have 6 and 2. 6 and 2. So 6 is 0, 1, 1, 0, and then 2 is 0, 0, 1, 0. We're gonna do the XOR again. So this is 0, 1, 0, 0, which is 4. And carry. So what's the carry? Carry is like carry is AND operation shift 1 and shift 1. So what is carry? So first AND operation makes 0, 0, 1, 0, and then shift 1 equals 0, 1, 0, 0, which is 4. Again, 4 plus 4 is 8, which is also good. So you might have already noticed that we started from 7 plus 1 equals 8, which turned out to be 6 plus 2 is 8. Now it's shifted to 4 plus 4 is 8. So I think we can already guess what's gonna happen is that we're gonna repeat another loop. So now 4x no 4 is that, so 0, this is the same, so this is 0 as XOR. So XOR is 4. What about carry, which is the AND operation, 4 and 4, and then shift 1, which is, so 4 and 4 makes 0, 1, 0, 0, and then shift 1 will make 1, 0, 0, 0, so which is 8. So we already know that 0 plus 8 is 8. This is also what we wanted. 0 plus 8 is 8. So it is actually working. We started from 7 plus 1, and then it turns out to be 6 plus 2, and then 4 plus 4, and then 8 plus 8, 0 plus 8 is 8. And then I think this is the last operation we need to do, is this XOR, new XOR is 0 plus 8 equals 1 0 0 0, because 0 is 0. So it's gonna simply get 8, and then carry, which is equal 0 0 0 0 and 8, which is 1 0 0 0, which is 8. So now we have 8 plus 0, which is 8, which is what we wanted. So this is really working. So I'm gonna start with, so let's create a variable y in x equals absolute value of a and b, and then while y, I decide, so I will create carry and XOR, and then I'm gonna put into x and y as XOR and carry. So this is what we done. When there is a carry, we're gonna repeat this process. You know, we started from 7 plus 1, and then 6 plus 2, and then 4 plus 4, and then x plus 0. So we're gonna repeat as a loop. When we have carry, we're gonna repeat this process. So what is XOR? As we know, Python operator is very simple. So x or y, and then as a carry, we need to shift 1 of the AND operator, so x and y, and then simply at the end we're gonna return x. Yeah, so this is working. So let's do the example. What we did is 7 plus 1. Right, so this is working. I'm gonna explain later why I take the absolute value. But what about the case when we have -1? This is not working because this is the addition. This is the addition. So now we have to compute subtraction, which is difference. How do we compute the difference between two numbers? Well, it's the opposite actually. It's the opposite. So what I mean is that, for example, this is a very good question. So let's do, instead of 7 plus 1, we can do 8 plus -1. So we want 7 as an answer. So first, as usual, XOR is that 1 0 0 0 1 0 0 0 and 0 0 0 1. So we're gonna first take the absolute value, and so that XOR is 1 0 0 1, which is 9. What about the carry? So carry equals, so we need 2 from 9. We need 2 as carry. So we're gonna do 8 minus 1, shift 1. But if we do this, we have 0 as a carry because 8 is 1 0 0 0, and then 1 is 0 0 0 1. So 8 and 1 is 0, and then whatever number we shifted, carry is 0. So this is not working. Not 2. So we need to do something different from the addition. So in case of subtraction, we can take the negation of 8, 1, and then shift 1. So what I mean is that, for example, we have negation of 8. So that means we're gonna flip 1 0 0 0 to, so we're gonna flip 1 0 0 0 to 0 1 1 1. and then do the AND operation. So 0001 and then 0001. What's the result? So AND operation will make 0001 and then do the shift. So now we have 0010, which is 2. Yes, this is 1A. So it seems like in case of subtraction, in case of computing the difference between two numbers, so we're gonna first treat as absolute. We're gonna first take the absolute value of -1, but when we compute the carry, actually this is gonna be borrow, not the carry, because we're gonna borrow 1 bit next to the left. Yeah, does that make sense? So instead of carry, what we want is how many bits do we need to borrow from the left bits? So why the negation of 8? Why the negation of 8 is working? Let's think about it. So intuitively, if we flip the bit and then apply the AND, that means, and if the one bit is matched, in case 1 1, so that means the first bit is 0 because we're taking flip negation of, we're getting negation of 8. So this is originally this was 1000, and it matched with 1 means originally the first position was 0, and then doing the subtraction means this position 0 needs to borrow 1 bit from the left. So this is what it's telling, is that at first position needs to borrow. So first position needs to borrow 1. So the reason why we also shifted 1 is that we are going to borrow from the left position, which is the second position. So that's why this negation of 8 and 1 and shift is making sense as borrow. So in Python, this is much more simple, rather than in Python, this is very simple compared to what we have done in this example. So while we have carry, we're still going to do the XOR operation as usual, but we're going to just put negation of X, and everything looks same. So let's do this example. So how do we? So anyway, we're gonna delete addition, and then we will simply compute the difference. Yes, and the 6 is output as correct. So the last task is that we have to define either we should compute the addition or difference. So then we already covered that case 1 can be computed as this. So we're just gonna copy and paste. So in case of addition, we're just gonna try this, and then in case of difference, we can just call else. Okay. So what about -7 -1? So it seems a little bit different. It is returning 8. but we want -8. So the reason is that we need to actually compute the sign. So let's start with sign starting from 1, and if a is less than 0, and then we need to compute sign equals -1. And then at the end, we are going to return sign times x. Yeah, so this is what we wanted. We don't know if it's difference or addition, but whatever it is, the input, we are first going to compute the sign and then return sign plus x. So what about the case when -1 and 7 is working? So how about we submit? Time limit exceeded. So what's actually going on? So 0 and 17. Why is it not working? Okay, so we need a plus b has to be bigger than or equals to 0. And then this should be working. Okay, so another case is this -14, 16, -14 and 16. So what is wrong with this example? So obviously this is the difference. But we want to have x as a negation as a 16 instead of 14. And we already defined x and y as absolute value of a and absolute value of b. So if this is 16 and -14, it is working, right? So because we already fixed negation part as x, we want 16 on top as a. So what we're going to do is that if a is less than b, in case if input is -14 and plus 16, then we want to just reset. We want to swap a and b. So return self of getSum as b and a. We just simply swap so that we can apply 16 as x and 14 as y. So this is what we want. Great. And now let's test it. Okay, finally, it's great. So I know it took a lot of time. To explain the concept, foundational concept of bits manipulation. But what's very important is that once we know how bits work as borrow and carry, each case for addition and subtraction, now we can be confident and compute the difference in addition without using plus or negative operation. So yeah, basically this is a good introduction as a bit manipulation without using Python's comfortable operators. Yeah, so that's it.